Hey, honors biology students. We are taking notes on atoms and elements for Chapter 2, Chemistry of Life. You should have page 1, and on the back of it, it's labeled page 2. We're going to fill out both of those notes right now, so let's get started. First of all, atoms and elements. This is should be all review, so I'll go through it quickly. As far as matter, all matter is made up of atoms. So let's look at the atom. In the atom, we have the nucleus, which is at the center. It is very dense, and it is positively charged. There are two types of subatomic particles in the nucleus. The protons, positively charged. Neutrons have no charge. They are neutral neutrons. So the net charge of the nucleus is positive. Electrons are in the electron cloud surrounding, and electrons are negatively charged. However, they have very little mass. So as far as charges go, the protons and electrons cancel each other out to make the whole atom neutral. That doesn't mean it's stable, but it's neutral as far as charges go. And as far as mass goes, most of the mass comes from the nucleus because the protons and neutrons are much larger than the electrons. So as far as looking at the periodic table, we have an element such as silver here with the symbol Ag. And it has an atomic number. This never changes. The atomic number is the number of protons. It should also be the number of electrons, unless the element has lost or gained electrons. In this case, it would be an ion. But protons and electrons, like we said up here, should be the same as far as number if the element is neutral. Now, that doesn't mean it's stable. The number of neutrons is the mass number, which is the big number of the mass of the whole, basically nucleus, minus the atomic number, which is just the protons. So like saying total protons and neutrons minus protons equal neutrons. So let's talk about elements. They are made of only one kind of atom, and they differ in the number of protons. So every element has a different number of protons as shown on the periodic table, so you can get your periodic table out too. And they're represented by symbols. Alright, so let's talk about how elements bond together. There are two types of bonding. There's covalent bonding and ionic bonding. This whole slide is about covalent bonding. So there are two types of covalent bonds. First of all, covalently bonded atoms are two or more different elements. Okay, they do share electrons and form molecules, so the sharing part is the most important part here of covalent bonding. Now, it's not like sharing like you learn to share when you're a child and you're selfish and you have to learn to share. It is sharing because they both want and desire electrons somewhat equally, so they have to share. So like hydrogen needs an electron here, carbon needs an electron, so they must share. Carbon shares one electron, hydrogen shares its electron, and so they each share one electron, and then it bonds them together. Now there are two types of covalent bonds, and the first type is nonpolar. Nonpolar just means it is outside of the actual molecule. There are no charges. Methane is a great example of a non-polar covalent bond. So it's two names, non-polar covalent. So to compare it, we need to talk about polar covalent bonds. In polar covalent bonds, we have hydrogen bonds over here in water, for example, having very weak attractions. And you can see the oxygen you can't really see it actually, but the oxygen has a greater affinity or desire for electrons than hydrogen. Hydrogen still wants electrons, but it's just not as strong as oxygen. So while they share, just like up here, the electrons spend more time around oxygen than hydrogen. So if I'm an electron and I'm buzzing around oxygen with my negative charge, I spend most of my time here, and I'll occasionally make a circle around hydrogen. But usually I'm located over here. And so if it has this hydrogen's electron and this hydrogen, it gives it a negative charge. And so it has this negative charge over here. You can barely see it. It's on your notes. And if hydrogen doesn't have its electron most of the time, it has a positive charge on this side because it still has one proton for each of these nuclei. And so hydrogen has a positive pole, oxygen has a negative pole, and so it is polar covalent bonds. Okay, so water is polar covalently bonded. So there's a little description there. Results in partially positive and negative ends or poles. And we are ready to go on to the second type of bonding. So ionic bonds are just one type of ionic bonds, and that is that they are formed when atoms or pairs of molecules lose or gain electrons on purpose. So for example, sodium here this is Na for sodium. It has 2 electrons in its first shell, it has 8 in its second, and 1 in its third. Well, this electron looks very lonely, and it does not want to be there, okay? This is, while neutral, because protons and electrons may be equal, it's very unstable, because the stability of an element depends on its outer, what you call a valence shell of electrons. And this one just has 1, and he's so lonely, and he desperately wants to get rid of it. Chlorine, on the other hand, and in the similar case, has this hole right here because he has 2, 8, and then 7 electrons here, and he's almost full, and all he wants is 1 more electron. Both of these elements are highly reactive because whenever they get around any other elements, sodium will force its electron on another element. Chlorine will steal an electron from another element just to fill up their shells. And so together, you can put NaCl together, and when this electron actually is transferred to this element, sodium's electrons transferred to chlorine, we have a sodium ion, because now we have 1 more proton than electron, because we lost a negative charge. And then chlorine has 1 more electron, 1 more negative charge, so it is, these are both ions. Positively charged +1, negatively charged -1. And then they stick together because with this positive charge and this negative charge, they make sodium chloride, which is salt. So the only other things over here, the loss of an electron makes a cation. So this is a cat. Remember the T with the positive charge. The gain of electron makes an anion. That's the anion. And together, they're neutral. They are stable, and everybody's happy. So that's it. Here's a graphic representing the sharing of electrons with covalent bonding and the transfer of an electron with ionic bonding. The number of times an atom can bond to another atom is determined by the number of electrons in its shell. Argon is the example here. We have argon atomic number 18. 18 protons, 18 electrons. So let's count them. 1, 2 in the first shell, 8 in the second, and then 8 in the third. And so we have 2, 8, and 8, very important. Argon's very happy, very stable, and it's a noble gas. It's all the way over to the right if you look at your periodic table because it is just full of electrons. So let's review. We're almost finished. Carbon, hydrogen, and oxygen bonds. So carbon has 4 outer electrons. So we count over to find that. 1, 2, 3, 4. So 4 outer electrons. And then you keep counting to find out how many it can actually bond with. So it has 1, 2, 3, 4 places to bond. So we show that by drawing its symbol and then a line for each place it has to bond. Hydrogen is over here, and so it has 1 outer electron, and so it needs to have 1 more electron to look like helium. So this is 1 and 1. Oxygen is over here, and if you count over, we got 1, 2, 3, 4, 5. It has 6 electrons in its outer shell. So 6 goes there, and it can make 2 bonds. So 1, 2. So it makes 2 bonds. And so we showed carbon with 4 for 4 bonds it wants to make. We showed hydrogen for 1 bond with what it wants to make. Hydrogen can only make 1 bond, and so it has 1 line. And oxygen can make 2 bonds, so it has a line on either side, or 2 lines. It can actually make a double bond, but it still is 2 lines for 2 bonds it can make. Each line represents an element sharing an electron, and you can draw these lines anywhere you like around this symbol. So we've got hydrogen with a line anywhere you like. They're all the same, okay? And the lines can go anywhere around the element, just like is shown there. So just to review, we have carbon, hydrogen, and oxygen bonds. You should already have this written down. Carbon has 4 outer electrons, it can make 4 bonds. Hydrogen has 1, it can make 1 bond. Oxygen has 6, it can make 2 bonds. So then we have a task where we are actually putting together molecules. So the first one we're going to put together is a 4-carbon chain. So if I tell you to make a 4-carbon chain, all you have to do is make a chain of carbon. So carbon, and then a bond, carbon, bond, carbon, bond, carbon. Then you're going to surround it with hydrogen because carbon's not happy. It needs 4 bonds to be full. So you're going to fill these up with hydrogen. Okay, hydrogen's like the filler. It's like the packing peanuts of the molecular world. So let's fill those up with hydrogen. So then your 4-carbon chain will be filled with hydrogen. Notice each hydrogen has 1 line because it can make 1 bond, and each carbon has 4 lines because it can make 4 bonds. All right? And the name of this is C4. That's 1, 2, 3, 4, H10, and you can just count the hydrogen to C10. For a ring, we actually make a ring of carbon, and I just don't have one single ring, but make a ring of carbon. So a 5-carbon ring, so there's 1, 2, 3, 4, 5, and then fill the rest with hydrogen. So each carbon, if I fill it with hydrogen, each carbon has 4 bonds and each hydrogen has 1 bond, and its formula is C5H10 if you count them up. The last one is draw the structure for CH3OH, which is methanol. Now, methanol is an alcohol, and so we are going to draw it here. So the hint on how to draw this is draw the carbon first. That's what you always do, draw the carbon first. Then add the 3 hydrogen, because it's CH3, and that's what this looks like, CH3. And then the O, and then the H last, because the H is a dead end. We can't add anything to any of these H's. They only need 1 line. Notice here we've added oxygen. Oxygen can make 2 bonds because it has 6 outer electrons. It has 2 places to bond to make 8. So this is CH3OH. Now try your practice problems in your homework and go ahead and complete your atoms worksheet.